Hi everyone. Um, this is my second class, actually, my second lecture. I just had an introduction maybe 3, 4 weeks ago, maybe before the earthquake hits Turkey. Um, in the first week lecture, I mentioned what the topics will be about this course. And mostly I will be teaching in this semester statistical inference related to confidence intervals and hypothesis testing mostly. And of course, in the end of the semester, maybe 2, 3 weeks, it will take me, or maybe more, I will be also dealing with regression analysis and correlation and regression analysis, which will be very useful in your econometric course. Today, I did lecture the Turkish section just some times ago, some minutes ago. I had the chance to practice using Zoom, and I broadcasted my iPad. I'm writing on my iPad directly, and then you can see on the screen what I'm doing. If I was teaching in the classroom at the university, and I would also use my iPad to broadcast my iPad, project my iPad on the board, on the whiteboard of the class. And this is what I'm doing now, actually. I'm physically not in the room, but I'm doing the same things. And we don't see each other physically, but you can see my video. I'm broadcasting my video. Okay, things changed because we are teaching from distance, using distance education. So I have no idea how the evaluation process will be because we have no official and official information about it. But basically, we are supposed to have 2 midterm examination and 1 final examination. And I think 30% from each of the midterm examination will be considering, and 40% from the final examination, and we take the average and we calculate the passing grade. We develop the grade intervals. But now I have no idea about this, whether we are going to have 2 midterm examination, whether we're going to have 2 midterm examination physically or online. And will I be asked to just present you a single midterm examination and 1 final examination? I'm not really sure about it. Okay. But we will learn in some weeks later, maybe 4 weeks later, we will have another official announcement, or maybe we can have an official announcement from the university administration asking us to tell you about the examination process. But I think since we're teaching from online, I don't think we will be asking you to come to take the examination just face to face within the class. This is my expectation and this is my guess, of course. So I think the examination will take place as a homework. It's sending you and the questions as a homework, and you supply the answers within some hours, maybe 2, 3 hours of time will be given, and to upload your answer key. Maybe you have the experience for distance education during the COVID-19, and you're not foreigner for such applications. Okay. Let me get back to the class, to probability and statistics, introduction to probability and statistics course for the second semester. In the previous semester, a lady from maths department was teaching you, and I had a look at the lecture notes from one of the students. I think Efe was there during the class, and he showed me, maybe Efe or maybe the other guy showed me.
Yes, right, teacher.
It was you, right? You showed me
Me.
the lecture notes. Yes. And I have seen the lecture notes, and mostly what you did in the previous semester was related to descriptive statistics and introduction to probability in the previous semester. But in this semester, we will be dealing mostly about the statistical inference. So the statistical inference is telling you to deal with hypothesis testing and confidence intervals. As I told you, we will also be dealing with correlation and regression analysis. And I don't know whether we can be dealing with categorical data analysis, which is related to chi-square analysis. We'll see. I'll try to do as much as I can for this semester. And it will be the course, if you learn the course well, and you'll see that in econometric course, you will have no difficulty. That's going to be very helpful for the econometric course. Okay. The course mainly, the book mainly I follow will be the one suggested within the syllabus of this course. Let me get to the first page of the book, just to show you the cover. First, Alan Blumen. That's the author of the book, Elementary Statistics, Step by Step. So I easily found this book on the internet. You can also download it, but I'm not really allowed to share that a part of the book or the book itself. But I can, of course, yeah, part of the book, yes, I can share with you during the class for each lecture week. I can share some part of the book, no problem at all. Okay, so that's the book. And you have done until chapter 6 in the previous semester. Now we'll be in chapter 7 related to confidence intervals and sample sizes. Okay, let me get to, yeah. But in my teaching way, I wouldn't consider the confidence interval separately. I will maybe mostly or probably use only the exercises here for this class. I will teach on my way this course. So what I did in the day class, in the third section, I will do the same things in here also. So we'll be here starting from confidence intervals and sample size, but I will change this subject as hypothesis testing and confidence intervals. And I will not be dealing with sample size. The calculation of sample size is something else. And there are some sample size calculator on the internet online for free. There's no need to learn such subject here. Okay, I'll get to the lecture notes I will write down here. Okay, I have forgotten to share my screen. I will broadcast my iPad. I will do the broadcast. Yeah, I did it. Successful. I'll stop sharing my screen.
Your microphone is off.
Okay, now do you see anything on screen?
Yes.
Yes, teacher.
Okay, now I broadcasted my iPad, but I can't see you anymore. If you want to stop me and ask something, just use your microphone because I can't see the screen. I can't see what you're writing on the chat box. So just use your microphone to stop me. Okay, I'm recording, and from the experience I had in the morning in the Turkish section, this will the Zoom process will end up within 40 minutes, maybe less. So we are already now 15 minutes away, and we will be teaching only 25 minutes. After it stops, I will try to reconnect. Maybe I can have 10 minutes a break, and then I keep going. Okay, we'll keep going in this way. We'll have compulsory two breaks we will have. And what I will do, I'll tell you about the recording. If you haven't had the chance to watch the lecture online lively, then I will record. I'm recording the videos and I'll upload the videos on the relevant week section of the Moodle. From the Moodle, you can also watch the lecture as well, the lecture videos. So you will not have a lecture videos there. What are you going to have? You will have a link. I will upload my videos on YouTube, and from the YouTube, you will have a link. You can just click on the link and watch the videos. That's what's required from the university. They will telling us just not to upload videos on the Moodle because it takes it occupies very much spaces. So they are asking us, they require from us to upload the videos on YouTube, just share the links for each week. And I will also share my lecture notes as a PDF file for each week. You can also download the lecture notes for each week separately, and you don't need to write down anything you like, or you can just prepare your lecture note just by following writing from the screen. It's up to you. Okay, today the time is, so today is 3rd of March. Oh, 2023. This is lecture 2 actually. Lecture 2. Okay. So in lecture 2, we'll be starting with one hypothesis testing. Testing. Confidence intervals. Okay. Okay, we'll be starting the first one with A, item A. Hyperus testing. And confidence interval for population mean to mean. Then sigma is No. Okay, today that's all we're going to learn. Hypothesis testing, confidence interval, the population mean, what sigma is known. Okay. What you did in the previous semester, you just studied descriptive statistics and you were just calculating the mean, and you did not try to make a comment from the mean. Let's say if you're wondering what the mean of the academic GPA of the students of Atılım University, and you might just try to pick up a sample randomly from the population. Let's say the population of Atılım University, maybe you have 10,000 students and you want to predict, you want to guess the academic GPA of the students. So to do that, what you do is you pick up a sample, you will think that represent the students of Atılım University, the whole students of Atılım University. So let's say you pick up 25 students randomly from the campus of Atılım University and ask each individual their GPA, and in the end try to calculate the GPA and find out the GPA is 2.51. Okay, in this case, what would you tell? Would you tell that the average GPA of the students of Atılım University is 2.51? It's just 2.51 belongs to 25 students. So from that calculation, you can't make an inference, but you need to work out statistical analysis to tell that what the average of the students and in what interval you can establish to tell about the average GPA of Atılım University. You can do that using the confidence interval calculations and by using the hypothesis testing, and you can test that whether the average GPA of the student is greater than 2.45 or less than 2.60 or different from 2.50 or anything like this. Okay, in hypothesis testing, we basically established three different hypotheses. Okay, the first hypothesis we established, the hypothesis HO, or the null hypothesis. We call it the null hypothesis. So the null hypothesis for mean population is in the null hypothesis, you have three different ways you can write for the null hypothesis. So this is before I write anything for the null hypothesis, I just tell you that this is the null hypothesis. Null hypothesis. And H1 is also another one. This is the alternative hypothesis. Okay. They have two hypotheses. Always we have the claim is always within the alternative hypothesis. We establish the claim within the alternative hypothesis. The null hypothesis is the opposite direction of the alternative hypothesis. Okay. So let's see for the mean population mu, the hypothesis. You can establish three different hypotheses. The first one, let me write you the first one, is mu is greater equal mu null. The alternative, mu is less than mu null. Okay, we call this hypothesis when you see this type of hypothesis, you can call it left tail, left-sided, or left-sided. Okay, and in second one, you will also have the null in the opposite direction. Now I will have right-sided, right-tailed. Mu is less equal mu null, and the alternative would be mu greater than mu null, and this is right-tailed. Or you can call it right-sided. Okay. And there's one more establishment, and the null hypothesis can be established as equality, mu equal mu null, and the alternative, mu is not equal to mu null. And this is two-tailed, or I can call it double-sided. Okay. Such hypotheses are tested with alpha level of significance. So that's alpha level of significance is like a probability is within 0 and 1, but mostly this alpha level of significance is very close to 0. So it's called alpha is also an error probability, is also called error probability. Okay. Okay. Such hypothesis, the test statistics we use to test such hypothesis, the test statistics. That's used to test such hypothesis can be given as follows. Okay, the hypothesis, I would call it Z calc equal x bar minus mu null, and I'm dividing this by sigma divided within the square root of n. That's the test statistics we use to test such hypothesis with alpha level of significance. Of course, we think that the population has a Gaussian distribution. Note that the population must have Gaussian distribution. If this is not satisfied, the Gaussian distribution is not satisfied, then you need to use some other statistics. They are called non-parametric statistics. I don't think I will be teaching non-parametric statistics for this course. I will not have time to be able to get to non-parametric statistics in this semester. But on your own, you can learn them easily because they are pretty straightforward. the statistics. They're not as complicated as the parametric statistics that I'm doing today. Okay. Okay, once you have the calculated statistics, test statistics, then it's easy to make up your mind whether the null hypothesis is rejected or whether you're supporting the claim that's included in the alternative hypothesis. Let me just write you the guide for this. Okay. When the constructed hypothesis is given as left-tailed, okay, if the calculated statistic is less than the critical values at alpha, then the null hypothesis is rejected with alpha level of significance. Okay. Okay, there is another hypothesis. So now we know how to reject the null hypothesis for left-tailed left-tail hypothesis. Let me copy this, duplicate this. Okay. I'll have another one. Okay. When the constructed hypothesis is given as right-tailed, I'll change this one. Okay. As right-tailed, then the calculated statistics is greater than Z1 minus alpha, then the null hypothesis is rejected. Then one more, you'll have one more. Okay. Don't forget this. Okay. When the constructed hypothesis is given as two-tailed or double-sided, two-tailed, if the calculated statistics, so let me change this stuff here. Within the absolute of the calculated statistics is greater than Z1 minus alpha divided by 2, then the null hypothesis is rejected with alpha level of significance. Okay. Okay, let me show you how we bring the critical values at alpha. Suppose that alpha equals 4.05, Z 0.05, and another one Z equals 0.95, and I could have another one that 0.975. I think you have learned all this values to bring from normal distribution table in the previous semester. And I also have the table values here. I brought them from the book, copied them to establish my lecture notes. So in the first one, look at the first one for 0.05. Okay, 0.05 from the first table. From the first table, you need to look for 0.05. Look 0.0274, 0.6, 0.05. So this is the closest value to 0.05. 0.050, 0.0505, 0.0495. Those two values are the closest to 0.05. So if you take this value, 0.0505, the equivalent Z value, critical value, will be minus 1.64. You see, this is minus 1.64. I can easily write here. So this one, Z 0.0505 is minus 1.64 from the table. And I know another one, 0.0495, and this is minus 1.65. Let me show you. Look at this one. 0.0495 is minus 1.65. Look here, minus 1.6. And I have here this one. You see, it's minus 0.6, minus 1.6 and 0.05, and it makes minus 1.65. So all this you have learned from the previous semester to read the table value. That's how I brought those two values. But I'm looking for this one, not this one, 0.05. And I have, this is greater than 0.05, this is less than 0.05, but it's approximately an average of those two values. So I can easily write this is as minus 1.645. Okay. It's an average of those two values, the average. So what about this one, 0.95? To get the value of 0.95, the Z value, I can't use this table because the highest probability for this table is 0.4641. So I'm looking for 0.95. So the second cumulative standard normal distribution table, if you keep going with this one, look, I'm looking for 0.95. So that is the closest value to 0.95, and this is 0.9495. So within between those two values is 1.6, and yeah, it should be somewhere here. No, sorry, here. I'm mistaken. It should be here, right here. So I can easily write that the Z statistics for 0.9505, which is 1.65, and Z 0.9495, which is 1.65. So you take the average of those two values to get 0.95. I'm mistaken here. 4.95 is equivalent to 1.645. And the other one, 0.975. So I can easily bring it from the second table. 0.975. I think we have it. Yes, there it is. You see, that's the value we're looking for. So it is you see 1.9 you get, and you get 0.06. So that's equivalent to 1.96. You see, that value is equivalent to 1.96. Okay, I can easily write here 1.96. Okay.
Teacher,
Understand? Yes.
we have less than 1 minute.
We have
We
less
have
than
a break or continue?
we might have a break, or if you like, you may keep going. It's up to you. I don't mind.